Hi guys, this is full of examples of a scatter graph and what a scatter graph does. It basically compares two sets of data. We can use this data to answer questions on facts and observations. It tells us a story. Now for question 1, the plots have already been completed for the purpose of shortening this lesson. We don't want to go on too long on each topic. So a scatter graph will have all these plots. They will ask you to plot them in advance. Like this one, it will give you all the plots and you will have to plot them. So for example, 140 and 3 is 140 and 3, and so on and so forth. Now, you would know how to plot by this point if you're actually on a scatter graph. So for this question, it says, describe the correlation shown. Now, a correlation is just a bunch of data, like what we've just seen, what we've plotted, and to read what it said, it's telling you something. Now, when the plots go up this way to the sky, it's called a positive correlation. When the plots are going down the stairs, it's called a negative. And when the plots are going all over the place and doesn't know which one to choose, it's literally just called no correlation. There is no correlation. That's it. So now we know what a correlation looks like and 3 options. We described the correlation for that one, height versus shoe size. Now we're looking at estimate the shoe size for someone at 168 centimetres tall. Once again, I've done this for you. So let's go along the bottom. The height. Now the height is 168 centimetres tall. So let's go along. This is our 168. I've guesstimated it here. I believe it to be right. And then we've got to look for the shoe size because that's what it's asking us. So you go all the way up to your closest dot where your line goes through. And we can see that the shoe size is 6. Now they say estimate because everybody can either read that differently and maybe put their 168 here, for example, and it would have gone up higher, or their shoe size aren't equally spaced. So there are lots of different reasons. That's why we estimate it. What would you expect the height to be for a shoe size of 6? So a shoe size of 6 is here. So go all along till we get to the cross, our plot here, which you can't see because of our line. Follow that all the way down. And that's our answer, 165. So we would expect the height to be 168 centimetres. Right, let's go on to another one. I hope you're understanding it so far. This question asks, hours revised versus a test score. Now, I've explained what a correlation is, and we can tell by looking at it straight away that the relationship between hours revised and test score is a positive relationship. It's a positive correlation because it's going all the way up to the skies. So the answer would be a positive correlation. That's our relationship. You see the word relationship used a lot with these. It is a positive correlation, a positive relationship. I'll just put C for short. If a student revised for 4 hours, estimate the test score. Haven't done the line for this one, so we're going to have to do it together. If a student revises for 4 hours, estimate their test score. So we're going to go all the way up here. And then we're going to draw a line across there. So I'm going to make a guesstimate here that it's 65. So the answer will be 65%. Explain whether this data shows a strong or weak correlation. Well, I'm quite happy that that is a strong correlation because they all go up nicely together. You know, there's no massive gaps in between. It's fairly close together. So I'm going to say this is a strong correlation. So there's all your answers for that. So this one, describe the correlation between TV hours and exam scores. So we've got our TV hours across the x-axis and our exam score on the y. So we already know this. It's going down the steps, so it's a negative correlation. So let's look at the question B. So estimate an exam score for a student who watches 8 hours of TV per week. I've already pre-done this. So we've gone from 8 hours all the way up to the coordinate, and we've gone left, and it tells us that it's 60%. So as you can see, it's pretty much the same concept as we go. Now the final one, it's saying suggest why this occurs, why this relationship occurs. So this is where you have to really think about it. You have to read between the lines. So if you think that hours per week is at 8 here, for example, that exam score is 60. What would happen if they didn't revise for, TV hours per week? If they watch TV more for 12 hours, say, a week, what would happen to their exam score? If you go across, it drops to 50. So what it's telling you is there's less study time. So the more you watch TV, the less likely you are to get a better exam score because you're not revising. That's what that means. Just another peek here. So because 12 hours was 50%, let's see what would happen if you only watched 2 hours of TV per week. If you go all the way up, that's 80% on your exam. So it makes a big difference, doesn't it, to revise? So suggest why I just put less study time. Temperature versus heating cost. So we know it's a negative correlation because it's going downwards, it's going down the steps. So we know that it's negative. Estimate the heating cost when the temperature is 10 degrees Celsius. So we're looking at 10 and estimate the heating cost. So you get your ruler, you go up and across. So it's saying that it's £70. And then finally, what happens to heating costs as temperature increases? Now, we're using the same concept. So let's have a look. So when the heating cost gets to, say, 40 £40, because that's cheaper, isn't it? What happens to the temperature? The temperature has risen to 30. So that means it's hotter. Yeah? So it's hotter. And what happens when it's hotter? You don't use the radiators, do you? You don't use the heating. So that means your heating cost has dropped to £40. Try again. So let's say it's freezing cold. 0. Let's go all the way up. And left, 90 quid. So as you can see, the correlation or the relationship between, so the costs go down. You could write something like this: costs go down, less heating is needed. As you can see, they're very easy to read. As long as you get to understand, I'll probably say these ones, when you're actually having to look at the relationship between the two, would probably be a little bit trickier for you guys. And then finally, there's no correlation. I've told you that, but by now you should know, is it going to the sky? Nope. Is it walking down any stairs? Nope. Where is it? It's all over the place. So there is no correlation, is there? There is no correlation. Suggest why there is no clear pattern. So now, it's one of them ones we've got to answer. So the age is across the x-axis. Yep. And the favourite number is on the y-axis. So why do you think we haven't got a correlation? Now, when you understand this, you'll get it. If I said to you, out of 10 people, who do you think's favourite number is 20? It might be one. It might be nobody. You just don't know, do you? Because it's independent on a choice that that person makes. So the answer to this, you would just put a favourite number's personal. It could be a random number. It could be, it's not age related. You see here, ages. Why can't a 40-year-old choose the favourite number of 10? It's a personal choice. So I would probably put not age related or age dependent, because I think that's an easier way of looking at it. But you can also put it's random or it's personal choice. As long as you understand what I'm saying, you can write whatever relates to it. It doesn't have to be written like that. So that's it. That really is I would say a pretty much overall check of a scatter graph. I'll probably say it was like a level 4. Yeah, I hope that makes sense. When you go to my website, there is a worksheet with lots of different questions and scatter graphs on there with the answers. So if you go there, you can practice what I've just taught you. Yeah. Bye.